We continue where we left off for the monsoon. Okay, so monsoonal development. The northern limit of the typical monsoon may be set about 25 degrees north latitude. Further north, the summer monsoon is not strong enough to overcome the effect of the traveling anticyclones, normally typical of the subtropics. As a result, monsoonal rains occur in June and also in late August and September, separated by a mild anticyclone drought in July. In South China and the Philippines, the trade winds prevail in the October-April winter period, strengthened by the regional, often gusty outflow of air from the stationary Siberian anticyclone. Their disappearance and the replacement by opposite southwesterly winds in the May to September summer periods is the essence of the monsoon. In any case, these monsoonal streams are quite shallow, about 1,500 meters, 4,900 feet in winter, and 20,000 meters, about 6,600 feet in summer. They bring rain only when subject to considerable cooling, such as anywhere along the steep windward slopes of the Philippines and Taiwan. On the larger islands, there are constructing effects. The slopes facing west receive most of their rainfall from May to October and experience drought from December to April, whereas the slopes facing east receive orographic rains, those produced when moist air is forced to rise by topography from September to April, and mainly convectional rains from May to October. The monsoon flow continues northward, intermittently affecting Colorado and Utah. Interactions of very moist air with the Rocky Mountains have resulted in some dramatic rainstorms and floods. The Big Thompson flood near Estes Park, Colorado on July 31st, 1976 was the result of greater 300 millimeter rain falling in 4 hours, leading to the death of 144 people who were trapped in the narrow canyon. Moist tropical airflow led to a record 435 millimeter equals 17 inches rainfall during 9 to 16 of September 2013, rated a 1,000-year event in Boulder, Colorado, with disastrous flooding in canyons along the Front Range. Meteorologists Vera, etc., and Marigold, etc., now consider that Central South America experiences a monsoon system, although it straddles the equator rather than being in the tropics, and its seasonal temperature variations are less. Nevertheless, Central South America receives over half its annual rainfall in the monsoon season. In September, the onset of the wet season starts in the equatorial Amazon and then spread to the east and the southeast during October. By late November, deep convection covers most of the Central South American from the equator to 20 degrees south, but is absent over the eastern Amazon basin and northeast Brazil during late November to late February. The main convective activity is centered over central Brazil and linked with a band of cloudiness and precipitation extending southeastward from southern Amazon toward southeastern Brazil and the surrounding Atlantic Ocean known as the South Atlantic Convergence Zone, SACZ. The strong convective heating over the Amazon sets of a Chaco low east of the Andes over northern Argentina. Chaco is a lowland in interior south-central South America. During March-May, precipitation amounts decrease and rainfall shifts north toward the equator. So this map, we can see the South American monsoon, and we're going to summarize about monsoon. The area of global monsoons as defined by the Global Precipitation Climatology Project is 80 million square kilometers, almost 16 of the global surface. Wow, that's a lot. And over the period 1979 to 2008, the area increased by 0.22 million square kilometers per year. This increase in area has given rise to an increase in global monsoon precipitation, but also to a decrease in monsoon intensity defined as the global monsoon precipitation amount per unit area. The expansion of the monsoon area is perhaps caused by a widening of the tropical circulation in the poleward branch of the Hadley cell. Now we're going to move to the next climate classification, which is high plateau. So look at this map. There are tons of plateaus. However, we're going to cover two regions. That's the two major high plateaus. The first one is the Tibet. Wow, where is Tibet? It's right here. The Tibet, also called Qinghai and Xizang. So in China, Qinghai is a province, Xizang is another province. We call it Tibet, Qinzang. So short for Qinzang. So Qinghai and Xizang, which covers 2.5 million square kilometers and averages 4,500 meters in elevation, and the much smaller Altiplano. So Altiplano is right here. Of Bolivia in South America, the Tibet Plateau, called the third pole, the third roof of the world, and also known as the third pole, stretches approximately 1,000 kilometers north to south and 2,500 kilometers east to west. It is bordered on the south by the Himalayan mountain ranges, and it encompasses several mountain ranges, notably the Kunlun and the Tanggula. Within itself, in the 300 kilometers long Kunlun in the north, which rises to over 7,000 meters, there is a glacier area of 12,200 square kilometers. In the moist Nigo-Tangula east of Lhasa, there is 10,700 square kilometers of ice, and in the central Tanggula Mountains, ice covers 2,200 square kilometers. Temperatures are low in winter, although there is generally only light snowfall due to the dry air in the higher western parts. Average winter-summer temperature is -20 to -25 degrees Celsius, 5 Celsius, and in the lower eastern areas there are separately -10 degrees Celsius to 15 degrees Celsius in the south. The high plateau of southern Qinghai and northern Tibet is underlain by continuous permafrost, permanently frozen ground, 100 to 300 meters thick. And this becomes discontinuous and sporadic in the south. The railroad from Golmao to Lhasa, built in 2006, crosses 550 kilometers underlain by permafrost that necessitate especially engineered embankments to prevent the ground from thawing. Annual precipitation totals in Tibet decrease northward and northwestwards from greater than 2,000 millimeters in the southeast to 50 to 100 millimeter in the northwest. The Asian monsoon influences the southern margins of the plateau in July starting the southeastern and moving westward. Precipitation is convective from large cumulonimbus cells, sometimes with hail. The snow line reaches 6,000 meters on the north side of the Himalaya and decreases northward about 100 meters per degrees of latitude. Okay, the third pole. So why we name Tibet Plateau the third pole is because it is currently used to describe a unique high mountain region centered on the Tibetan Plateau that stores more ice and snow than anywhere else in the world outside the polar regions. The third pole contains the world's highest mountains, including all 14 peaks above 8,000 meters, and is the source of 10 major rivers with an average elevation of over 4,000 meters and an area of more than 4.3 million square kilometers. The third pole is characterized by complex interactions of atmospheric, cryosphere, hydrological, geological, and environmental processes that have a significant effect on the Earth's biodiversity and climate and hydrological cycles. These processes are critical for the people of surrounding regions of Afghanistan, Bangladesh, Bhutan, China, India, Kazakhstan, Kyrgyzstan, Myanmar, Burma, Nepal, Pakistan, Tajikistan, and Uzbekistan. The meltwater from 12,000 cubic kilometers of glaciers of the third pole supplies permanent flow to most of Asia's major river systems. There are significant climate impacts and feedbacks associated with this unique region. The third pole plays a prominent role in the evolution of the Asian monsoon system, which is critical for the precipitation pattern in the region, and snowfall amounts on the plateau can both weaken or prolong the summer monsoon system in the region. Conditions in the third pole affect the atmospheric circulation patterns in Eurasia and thus significantly influence the climate system in the northern hemisphere. The fluctuations of climate have strong effects on the glaciers and lakes of atmospheric circulation pattern in Eurasia and thus significant influence the climate system in the northern hemisphere. The fluctuation of climate have strong effects on the glaciers and lakes of the third pole, but also on water supply and social stability for wider region. As glaciers retreat, water volume and flow are likely to decline and could become seasonal rather than year-round in some of the drier regions. Additionally, the observed thawing of permafrost will result in the release of greenhouse gases such as methane and carbon dioxide to the atmosphere, contributing to global climate change. So, The Tibet Plateau lies between the Himalaya range of the south and the Taklamakan Desert to the north. You can see from here. Natural color satellite image of the Tibet Plateau and Himalaya as seen from the space looking south over the Tibetan Plateau. It's from right here.